Welcome to this feedback video for assignments 9 and 10. We received 15 submissions, of which 13 were shared, so that's really nice to see. We had many circular strategies, you also had fun in doing so, and you formulated some very interesting takeaways already. In this video, as always, we will show you an overview of the work that you've submitted. We'll address some of the examples more in depth, and we'll give you we'll address some of the questions, of course, that you had. We'll address the key takeaways and the upcoming assignment. But first, an overview. As you can see, many different scenarios were explored, which is really nice. And also, you combine different scenarios into one, so that's really advanced work, and we like it. If you want to implement one of the solutions in practice, be aware that if you combine different circular scenarios, you also have to invest in different lines, so both refurbishment, remanufacturing, and maybe recycling if you do it in-house. So even though you get a higher collection or a higher circularity, it may be smarter from an economic perspective to focus on the best performing scenario. Whatever is best, of course, depends on your specific case, so I'll leave that up to you. Sarah remarked that her refurbishment scenario was the most interesting, something she didn't anticipate beforehand. And that's of course nice of doing an assessment, that it will build your insights and give you new information on which you can make your decision. Asafeh liked the holistic insight that this analysis gave her. So it really made her think about how to enhance circularity and potential value capture. And that's of course one of the main purposes of this tool. So that was nice to read. You may remember that in the previous episodes, Arno commented on the huge amount of value that was lost in his linear scenario. He modeled a remanufacturing scenario that is capturing some of that value, as you can see here, and he's working on the cross sorter. And even though his potential value capture index is only 11%, which may not seem as a whole lot of money, if you look at the specific values, you can see that it's over 26 million euros worth of money. So very worthwhile to investigate in more detail. His colleague Robin commented that whatever you do, collection is key. Right? It starts with collecting the product in a way that you can facilitate high quality refurbishment, remanufacturing, or recycling. And Irina had the same insight, and you're both right, of course. It's key that you design your system in a way that it enables a high percentage of collection. Another example was shared by Timon, who worked on the Confovar product. So I think it's a business-to-business scenario, and he modeled also a remanufacturing scenario, where he analyzed his design and said about 84% of the components can be remanufactured, and part of the rest can enter an open-loop recycling scenario. This results in an overall potential value capture of 60% and a circularity of 74%. So as you can see, also a great strategy to go circular, worthwhile to investigate further. Of course, there's also critical aspects to look at, and Tom made a nice remark on that, an aspect when going circular which becomes more important, namely time. Because things change over time. You have fashion, you have market trends, and of course you have innovation. And what he remarked is that its potential value capture becomes more uncertain over time. Sometimes in his case, he says market trends are not predictable enough to invest in a long lifetime. So to invest in the future and make sure that you can earn it back. It's a valid point, and there's also some things you can do in terms of the design to work with that. So we've put some on the list. The first one, of course, is timeless design. Making sure your product is designed in such a way that it's not prone to fashion trends and that it will just be valued by your customers over a long period of time. That's not always possible, of course. Then one of the key strategies you can do is focus on the internal components that are not prone to fashion. And for instance, remanufacture the valuable internal components such as engines. Yet another approach is to change it around and make sure that your product can be adapted over time. So one thing you can do is to design for upgradability, where you can add modules, exchange modules. So for instance, add a better camera module. And also you can make sure the design can be updated to fashion so that it can have an outer panel of a different color, of a different texture, etc. And lastly, if that's no longer possible, you can still design for recycling to ensure that you can make use of the outer loop and increase your overall circularity. So those are some of the tips we wanted to share with you. Finally, Lizzie and Stefan are curious about the environmental impact of their solutions, which is a valid point. And because what you assess in the circularity calculator and what you assess in LCA, so life cycle assessment, are not the same things. I could spend an entire feedback video on this topic, but I'll try to make it short. In essence, what you try to assess in the circularity calculator is the degree to which your solution already fits a circular economy. And you can see how much resources you can save by going circular. On the other hand, in an LCA, you assess the environmental impacts of your solution in today's mostly linear economy. And those two are not by definition the same, right? If you need to transport your product over a long distance and you use transportation means that are not yet circular, it could be that something is more circular, has a higher circularity, but could also have higher environmental impact. So it's really key to compare the two. So if you're interested in this topic and have the time, you can look at that in more detail. I would definitely advise you to do so. So Lizzie said, I'm curious how the scenarios would score on environmental impact. As you may recall in hotspot mapping, you already get a flag for those components that have the highest environmental impact. But if you want to go beyond, there's several programs you can use to do a quick scan assessment of the environmental impact. So these are some of the programs. So CIMA-Pro and Gabi are extensive programs, so you can do quite rigorous analysis with those. But on the other end of the spectrum, there's also very simple, easy to use and free programs such as the Equalizer and Edamat. And we will share some links for you if you're interested. If you would like to discuss this topic in more detail, let us know, because then we can bring it up during the final webinar. Yes? Okay, let's go to the key takeaways. So first of all, what we already addressed, collection is key, right? It's vital, it's a starting point of your new solution. And it can be simple, but it also can require a different business model. Like some of you investigated the leasing model, which can have quite some implications for your company. Next up, changing a business model can of course have a huge impact. And it's something you really need to investigate in more detail. But knowing the potential resources you can save and the value you could capture gives you a first insight of whether or not you want to investigate this further. Next up, a key takeaway has to do with time. Circular business reaches beyond the first use cycle of your product. And you can address this both in the product design and in the business model design. So thinking ahead about upcoming product generations and revenues over time rather than revenues from first sales. Very nice takeaway. And finally, you can realize circularity and potential value capture with each of the strategies that we addressed. It's not per definition that one gives a higher score than the other. Some of you said refurbishment gives higher scores than remanufacturing, but it really depends on your product, whether the parts are fit for that strategy. What you can say, what I also mentioned here and what you can see in this picture, is generally recycling gives a lower potential value capture because the value embedded in the materials is generally lower. because companies add a lot of value during manufacturing and assembly of their products. So that you could take as a general key takeaway. But other than that, it really depends on your case. And it will be nice to look at some of the other examples to see if they got to the same findings as you did. So those were the key takeaways. Up next, already the last episode of this course, unfortunately. So assignment 11, June 27, is your reflection. So wrapping all of your findings together. We also have a last Miro board where you can share your findings. And especially this week, it will be very nice if you can give some feedback on a fellow participant, both to improve your own insights by reflecting on another product than you analyze yourself, and by getting feedback. Of course, you can also improve your reflection. And finally, we hope you can make it for the final webinar on June 29. Looking forward to see you there.